Okay, let's get going on this review here. I've chosen purple for the festivities. Unit 2, test review. How many ways can 40 kids be separated into these groups? Again, when you're doing multiple groups, just go 40 factorial over 10 factorial, all the group sizes. Okay, so the total is 40, and then that's all the factorials. If there are 10 groups, so the question here is what would happen if there are 10 groups? Again, these are all factorials. But if they're indistinguishable, there are 4 groups of 10. You're going to divide by 4 factorial. Okay. Only clubs. Only clubs. You just take all 5 cards are from the clubs. And you can also say that you're choosing none from the non-clubs, but there's no point to do that because that's 1. No sevens. So no sevens. You could do this. You could just get rid of this. But what I've said is there's 4 sevens. I'm choosing nothing from them. There are 48 non-sevens. I'm choosing 5 of them. Okay, that's one way to do it. That's the best way to do it. Okay, 4 of clubs and the 4 of hearts. So you're getting the 4 of clubs and the 4 of hearts. So what has happened here is there's one card, the 4 of clubs. There's another card, 4 of hearts. And then I have, I don't know, question mark, question mark, question mark. So I need 3 new cards out of 50, okay? Because there's the 2 cards that I have are gone, and then that's what's left over. Okay, 3 face cards and a 5. So first let's choose a face card. There are 12 face cards, remember that? So there are 12 face cards. I'll choose 3 of them. Then there is a 5. And then here I have to get these cards out. I have the face cards, 12 and 4, that's 16. 52 subtract 16 is 36. So 36 non-face card and non-5s, and I want one of those guys. So all these are multiplying. Almost always multiplying, except for an F here. Exactly 3 aces, so I choose 3 of the 4 aces, and then there are 48 other cards, and this is wrong. This should be a 2, because it's a 5-card hand. Next up, at least 4 hearts. Okay, so this is 2 different things. Someone said it this way, and I think it's not a bad idea. Think about this. If you're going to do, when do you add? You multiply when you're doing something at the same time, and you add when you're doing it at different times. So that's one way to think about it. So at least 4 hearts would mean I have 4 hearts or I have 5 hearts. So at least, looking for words like at least or more than or that sort of thing, that will get us a situation where we're adding. So we have the 4 heart situation and the 5 heart situation. So there are 13 hearts, and I choose 4 of them. That means of the non-hearts, I choose 1. And then there are 13 hearts, and I choose 5 of them. And of the 39 non-hearts, I choose 0. So you find out what this is, and you add them together. Okay, so different cases there. I have 4 dogs and 7 birds. How many ways can I do that? Choose my top 3 pets. Favorite pets, if the top 3 must include 1 dog and 2 birds. So depending on how you interpret this question, let's just start it off, and then I'll add a second part to it. So I choose 1 of 4 dogs and 2 of 7 birds. But if I'm going to rank them now, depending if you want to say that you're ranking, I don't know if this necessarily says you're ranking, but if you were to rank these as first place, second place, third place, what you're going to do first is select them. And then after you select them, then you're going to rank them. If you chose 3 things, you need to rank them, and they can be ranked in 3 ways. Okay, so that's a neat question. Here I'm choosing 3 letters out of 4, and I must order them, so that's a permutation, so 4p3. Another option is just to go 4 times 3 times 2, okay, for the first spot, second spot, third spot. Here I'm ordering these words or letters in a word, and I must consider the fact that there are 2 b's, so I divide that by that. These here, you need to be able to do this, okay, to expand and then simplify. So this is 95 factorial over 93 factorial and 2 factorial. So what happens is that's 95 times 94 all the way to 93 factorial, right? Because it's 93 times 90, 92, blah, blah, blah. And these cancel out, and you're left with this. 2 factorial is just 2, and then you could divide these out if you want to or whatever. But at this point, you can put this in your calculator. Here, the point to be taken is that 0 factorial is 1. Keep going. That page is easy. Nothing on it. And that's it. So now we're going to do some of these multiple choice questions. I'm going to skip a couple. Let's switch to green here. Why not? So here I'm making a word kind of UUU or UU, DDD. Okay. So 3 up. I got this wrong. Same answer, but it's 3 up and 2 down. Okay. Up, 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 down, down, down. That's a word 5 over 3 factorial, 2 factorial. Here, it doesn't say you can't repeat, so it's 6 choices, 6 choices, 6 choices, 6 choices, so multiply them all together. This is a good question. Trees must start with a consonant and in a vowel. Well, if you look here and you're confused because there's 2 E's, this will it works its way out. It's a better question if there were other vowels too, but anyway. So I have a, what am I doing here? I'm doing a 5-letter word. Okay, so 1, 2, 3, 4, 5-letter word here. And it must end in a vowel, which means it must end in an E because they're the only vowels. And it must start in a consonant, which means I have to start with TRS. So let's figure this out. One option for the last letter, 3 options for this letter, and then when I'm done, I've taken 2 of the 5 letters out of here. So I'm left with 3 letters, and I must order them in 3 factorial ways. So it's 3 times 3 factorial times 1. C and E must be together. Well, remember when we do things together, we must order them first. Is it EC or CE? And then they're considered one entity. Just times that by 5 factorial. This one here is a good question. 3-digit odd number. So if they're odd numbers, they end with an odd number. But the only issue with this is you're going to have a different situation if you start with a 6 or a 7. If you start with a 6, then your final numbers can be a 3, 5, or a 7. So if you start with a 6, you have no option. You've already said I'm starting with a 6, so there's only one way to put a 6 in there. And then you end with a 3, 5, or 7. So you have 3 options for the last number. And then once you've chosen this number and this number, you had 2, 4, 6 numbers. 2 are gone, so you're left with 4. So it's 1 times 4 times 3. Okay. In this case, it's the same sort of thing, except if you start with a 7, sure, I have one option here, but the 7's gone. So now I only have 2 options for the last number. So you actually have less options for a number that starts with 7 that is going to be odd because one of the odd numbers is gone. Kind of neat, eh? And then times 4, and then what you do here is you add those 2 together. Okay, different cases, add them together. Here it's a simple question. You're just joining these 9, choose 2. Here, once this person, Carmen, I guess it was, is out, you're not really choosing 5 from 12, you're choosing 4 from 11. Oh yeah, this is a great question. So here I choose my 3 vowels. So there are 3 vowels and 5 consonants. I choose 2 of the 3 vowels and 3 of the 5 consonants, and I've chosen the letters. So let's say I chose them. I chose T, and I chose G, and I chose I, and I chose A, and I chose L. Okay. Yeah, that's right. 3 consonants, 2 vowels. So now they're my letters, but I haven't made a word yet. And to make a word, I can do that in 5 factorial ways. So you're choosing, then lining up. Kind of a neat way to deal with this question. Okay. So you're going to multiply that, and then times 5 factorial. Here, don't bother, but the answer is 11 plus 10 plus all the way down. Think of it this way. If I come in and I'm the first person, and how many hands do I shake? I shake 11. I don't shake my own hand. Okay, that's bizarre. That's holding hands. And then once I'm gone, then the next person, I've already shook or shaken. I don't know, shooken everyone's hands. And once that's done, I'm gone. You can just kind of get rid of me, really. And then everyone else shakes hands, and the next guy walks up and he shakes 10 hands, right? So he doesn't shake mine because he already shook it. And then there's 10, and then the next guy shakes 9 all the way through. Okay. If there are 3 cars and 4 motorcycles and they alternate, the one thing that you would realize here is that it is a word question, but it's a little different because you have to start with an M, right? Sorry, it's not a word question because they're distinguishable. I take that back. It's an ordering question, but you have to go MC, 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 M. If you don't, you can't alternate. So you can try it out, but it won't work. And then you can just ask yourself, okay, let's line up the M's. I have 4 options for this one because there's 4 motorcycles, 3, 2, and 1, and then 3, 2, and 1, and I multiply all this through, which really is 4 factorial, 3 factorial also. This one's great here. How many ways can you get cards? I'm not really sure what they're asking. If there's repetition, you can do this. If not, it's this. Okay, so you can check the answer there. So you could have taken that both ways. If a 5-card hand is dealt 52 cards, how many cards were they're all the same color? Well, remember, a lot of people were messing this up. There's red and there's black, and there's 26 of this and 26 of this. So you're going to choose 5 of this and none of this, or the other way around, right? So it hasn't said if they're all red or all black. So there's 2 options here. One where they're all red and one where they're all black. So you can either add this to itself or multiply by 2. Multiple choice question, 4 times 4 times 4. There are 4 options, right? You can repeat, so it's 4 times 4 times 4 times 4. And here, this is a good question. Which of the following is not a term in this expansion here? Well, what I want to do is I'm kind of cheating here. You could have looked at this and said, look, this is the same as this, and this is the same as that. I messed this up. Wait a second. Hold on a second. I messed this up. My question is better. So forget this question here. But my question is this. What I would ask you is this. Let's redo this. This is what I would ask you. Okay, pretend this is the question. 2x minus 3y. I realize I made a mistake here. Anyway, so 2x minus 3y to the 4 is what I'm looking at here, and I want to find the third term. That's what I'm going to ask you. Okay, I'm not going to ask you to expand this, but I might say find the third term of 2x minus 3y to the power of 4. So remember when we do this, you set this up like this. You have c, and then you have 2x, and then you have minus 3y. Okay, so that's a 3. And what you're going to do is you're going to put a number here, a number here, a number here, and a number here, okay, based on the pattern of expansion. And what happens is this number here is the same as the 4 here, so that 4 goes here. Now it's the third term. Don't put a 3 here, right? Remember that when we start off, so if we started this off, if you had Pascal's triangle, the first term in the fourth row is 4c0, okay? So if this is a 4, the first expansion is 4c0. Then it's plus blah, 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 4c1 all the way through. So the third term has a 2 here. This 2 turns into this 2 over here, okay? This 2 goes there, and then this 2 is actually 4 subtract 2. So how do you get this number here? It's that subtract that goes there. So if I said to you, let's do a better question here. Let me just come up with a better question here. And I had a plus 3b to the 10, and I said, give me the sixth term. Okay, I'm not going to actually work this out. No, hold on a second. Let's make this a really good question. Give me the second term. Okay, second term. No, we'll go third term. Hi. Start again. I'm Mr. Lubos. And let's begin. Third term of a plus 3b to the 10. Okay, so what that means is I go like this. I have this, I have a, and I have 3b, and I have a c here, and I want to figure out what numbers go here, 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 and here, and what I'll do is switch over here. So because this is a 10, this is a 10, and I want the third term, I put a 2 here. Okay, the first term is 0, the second term is 1, the third term is 2. And then this 2 goes here because if you notice when we expand this, we get 8. The first term will have 3b to the 0, the next will have 3b to the 1, 3b squared. So anyway, this number is the same as this, and this number here is going to be 10 subtract 2, which is in fact 8. So let me clean that up for a second here. Okay, that's going to be 8. So let's expand that. That's going to be 10 factorial, 8 factorial, 2 factorial, or the other way around, a to the 8. And this is 3b squared, which would be 9b squared. Remember here that you have to square the 3 also. So that's 10 times 9. So if you throw this in a calculator, or however you get this, as 10 times 9 divided by 2. 10 times 9 is 90 divided by 2 is 45. A to the 8, but you also have the 9b squared. So I have to also do 9 times 45, which I believe is 505. No, it's not. It's 405. Okay, so 45 times 9 is 405, I think. Is that right? 450 subtract 45. I think that's right. A8b squared. So don't forget to go 3 squared gets me the 9, but then I have to multiply this in here. Okay, is that right? 81, 810. Yeah, that's right. I think it's 405 is right. Okay, so make sure that you don't, that's a 9, right? You don't forget to multiply this by this to get this number up front. Okay, and then clean everything up. And that's it. Okay, so that's test review. Good luck. You'll ace everything. Don't worry about it.